Hey there, this is Organic Chemistry Simplified, and our goal is to make organic chemistry simpler. The goal for this video in particular is to develop a framework for attacking organic chemistry synthesis problems with confidence. And the way we're going to learn that is through an aromatic problem here. So we're going to learn about aromatic synthesis problems in the process. So I'm going to go over the framework quickly within the context of this problem. So the first step is what is the same and what's different. Well, what's the same is that we have this benzene ring structure. We have that in both our starting material and our end product, right? But what's different? What's different is we've tacked on this SO3H group and the Cl group in a meta relationship. That's going to be important. So step 2 is what specific changes are made, right? Well, we've tacked on this SO3H group and we've tacked on the Cl group. Those are the specific changes that are made. So step 3, how do I make each specific change? Keeping in mind that it may take multiple steps. So how do I tack on this SO3H? How do I tack on the Cl, right? Well, the easy part is actually what reactions we need to tack on those groups, because those are the things we can just memorize, right? The key is to figure out what order we have to carry out those reactions, because one reaction could direct a parallel relationship, which is the two groups are across from each other on the benzene ring. Another group could be a meta-directing relationship, right? So we have to keep in mind what order we carry out these reactions. So we know it is a meta relationship, right? So what group do we have to put on first to create a meta relationship? Well, it's the group that withdraws electrons through the pi system. Okay? I'll repeat that again. It's the group that withdraws electrons through the pi system, right? Because if we have a benzene ring and we have this group, I'll just put a group here, right? And if it withdraws electrons through the pi system, we're going to have a partial positive charge here, here, and here through resonance, right? So the only place that has sufficient negative charge to attack an electrophile, because our benzene ring is a nucleophile, it's at these two locations here, and those are the meta locations, right? So the question we have to ask ourselves to ask ourselves which reaction is carried out first is which of these withdraws electrons through the pi system, and that's this SO3H group, right? So what we have to do is we have to carry out the reaction that tacks on SO3H first, and that's SO3 H2SO4, right? That's going to add an SO3H to our benzene ring. And remember, you have to have these reactions memorized. Okay? And next, now we're going to add that Cl. And we do that with Cl2 and AlCl3. Now this AlCl3 makes the Cl2 more electrophilic. That's going to make it more susceptible to nucleophilic attack by the benzene ring. And that's going to bring us to our product. So the fourth step is to actually map out the synthetic pathway after you've done the heavy lifting. That's what we've done here, right? So the key is that we had to put on this SO3H group first, because the SO3H group was meta-directing, So the SO3H group directed the Cl to the meta position to create a meta relationship between these two groups. So as you can see, when you have a systematic, methodical method for attacking these problems, it becomes a lot easier. And it's not just guessing, and it's not just hoping you get the right answer, but you're actually coming up with a system to help you attack these problems. Okay, so I'm going to repeat the framework once more. The first step is what is the same and what's different. The second step is what are the specific changes that are made. The third step is how do I make each specific change. I want to keep in mind that it may take multiple steps, and I also want to keep in mind the little nuances that that help me decide, what order we want to put the reactions in. And the last step is to map out the synthetic pathway and formalize it in a series of reactions. So hopefully that helped, and if it did, please subscribe to our channel. Please like the video, and if you have any comments or questions, please leave them below. I'll try to get back to you as fast as I can. And remember, this video is to help you simplify and learn organic chemistry. So the more you participate, the easier that is. And I hope you got a little something to help you out as you were doing this, as you're gonna tackle more of these problems. Till next time.